Yeah, that's fine. Okay. Can you hear me all right? Yes. Okay. All right. Well, welcome, ladies and gentlemen, to the 2013 Holyoake Lecture. My name's Andrew Copson. I'm the Chief Executive of the British Humanist Association, and we're really pleased for this Holyoake Lecture to be able to introduce to you the new President of the British Humanist Association, Jim Al-Khalili. Now, the Holyoake Lecture is named in honour of George Jacob Holyoake, who, as well as one of the founders of the secularist movement in the UK, in fact he coined the word secularism, was also one of the originators of the cooperative movement. So this lecture is named in honour of him, and it's held here in Manchester in honour of this city and its long history within the cooperative and also the secular movement in this country. But the theme of the lecture is far distant from Holyoake's life today. At about the same time as George Jacob Holyoake was plying his secularism, our speaker's great-grandfather was a grand Ayatollah and spiritual leader of millions of Muslims. And that contrast says something interesting about the world that we live in today. Every humanist will acknowledge that there is something universal in human culture, which is what humanism is about. It's about saying there are today and always have been men and women who make sense of life, not through reliance on the supernatural, but with a naturalistic approach. Men and women who find their values and their meaning not in any religion or any authority above, but in the here and now, in other people and in the life that we know. And this is not just science and reason, and humanism is not just a modern phenomenon, though it's found its greatest flowering in modern times. It can be found and discerned and detected in the traditions of different people all over the world. And it's touching on one specific aspect of this view of life in one specific part of the world that our lecture will be this evening. So the title of the lecture is The Forgotten Legacy of Arabic Science. The speaker this evening is Professor Jim Al-Khalili, and I invite you to welcome him to give his talk.
Thank you very much, Andrew. Well, good evening, everyone. So, yes, it's a great pleasure to be here, to be giving the Holyoake Lecture. It's a great pleasure and honour to have been asked to take over the role of President of the British Humanist Association. I'm now almost a year into my role, settling into the role. I haven't embarrassed Andrew or anyone in the association by saying anything out of order. The subject of my lecture this evening is somewhat, as Andrew mentioned, removed from humanism and removed from my own specialist area, which is theoretical physics. So, first of all, let me say why I've chosen this topic and what it means to me. As Andrew mentioned, it's true, my great-great-great-grandfather was an Ayatollah. I was born in Baghdad. My father was born in the holy city of Najaf in Iraq. My mother is a Christian. She's a church-going Christian. She drags my dad to church on Sundays if he can't find an excuse not to go. And he goes along and sort of listens and mumbles at the back. What a load of nonsense this is. But I think it's all good-natured. It may have been then inevitable that I was going to, especially as becoming a scientist, I was going to somehow fall between the two stools and end up not being in the least bit religious. But the story I'm talking about is of a particular period in world history. I'm not going to be making any special pleading for the Arab world or Islam as a religion. But if it comes across in a positive light, then so be it. What I want to do is tell you a story that many in the West aren't familiar with. I should say, first of all, that I've chosen the term Arabic science very carefully. By Arabic, I don't mean the race, the Arabs. In fact, many of the characters that I'll be telling you about this evening weren't Arabs. Many were Persians. And given how large the Islamic Empire was, inevitably there were many other nations and countries and cultures and religions that fell under the umbrella of this large empire. Arabic, by Arabic I mean the language in which all the scholarly texts were written. Now, some people say, well, why don't, this was part of the medieval Islamic Empire, why not call it Islamic science? Well, I don't call it Islamic science no more than I would refer to Christian science, of course, which means something completely different. Or indeed Jewish science, which was a term used as a derogatory term by the Nazis to denigrate and downplay the work of scientists like Einstein in the 1930s. In principle, you should not label a period where science has developed based on the religion of those who practice it. In any case, many of the scholars in this period who made a very big contribution to science and learning in medieval times weren't Muslims. This was a time, a period, when Muslims, Jews and Christian scholars all worked together, somewhat in contrast to the world today. So the story I want to tell you is about this period in the history of science that falls between the fall of Rome and the destruction of the Library of Alexandria and the Renaissance and the birth of modern science in Europe. It's a period of over 1,000 years. It's a period when, on the whole, we refer to it as the Dark Ages, and we sometimes forget that those Dark Ages really only refer to Western Europe. The rest of the world didn't have any Dark Ages. There were great civilizations and cultures that flourished in the Islamic world, in India, in China. Science develops not in a vacuum. Cultures, civilizations will promote and encourage scholarship and learning and science, and as a race, we learn about the world around us and our place in the universe. And that body of knowledge tends to get passed on like a baton in a relay race. And so the ancient Greeks were wonderful scholars. They provided us with so much in philosophy, in mathematics, in medicine and astronomy. That knowledge was passed on to the Islamic Empire and then later to Europe. So I want to tell the story of that period from the late 8th century AD all the way through to the 13th, 14th, 15th century until the rise of Europe again. And to show that it's more than simply a group, a culture which looked after and protected Greek knowledge and scholarship until Europe reawoke and was ready to reclaim it again. I want to tell you some stories about many wonderful advances and many great scientists whose names really should be much more familiar to all of us, not just in the Arab and Islamic world, but everywhere, because it's part of our shared humanities heritage in terms of the way science has evolved. So those of you who are darn lucky enough to have bought a copy of my book, Pathfinders, will notice this is a different cover. This is the hardback cover. I just want to say something about the title, because originally I was going to call it The House of Wisdom, named after that almost mythical academy in Baghdad, known in Arabic as Bayt al-Hikmah, which flourished under the Abbasid dynasty. And The House of Wisdom was a lovely poetic title, and it seemed perfect, and my publishers, Penguin, were very pleased with it, until we realized that there was a book with the very same title, written about the very same subject in America. Someone else had beaten me to it. Well, originally, my publishers said, look, don't worry. They were quite bullish about it. They said, no, let him worry about another book It's going to sell far more than his with the same title. And then at the last minute, they got cold feet and decided we really should find another title. And so we went for Pathfinders. Now, Pathfinders comes from this quote. He who finds a new path is a pathfinder, even if the trail has to be found again by others. And he who walks far ahead of his contemporaries is a leader, even though centuries pass before he's recognized as such. Now, I had heard that quote before, and I thought it was attributed to a North African scholar by the name of Ibn Khaldun. Now, Ibn Khaldun was he's regarded as the father of social science, almost the father of economics. He was a great polymath, but I couldn't find anything in his writing where I could locate this quote. But then we discovered that it was in fact a quote about Ibn Khaldun by his biographer, Nathaniel Schmidt. But actually, so referring to Ibn Khaldun as a pathfinder, but I felt it's a very nice title because it really does, I think, fit well on the shoulders of many of these scholars of this medieval period. These men, not so many women, but I think that's probably true in the history of science in general. There weren't that many great women Greek philosophers either. But so these scholars were pathfinders. Very often, a lot of the work and the discoveries and the knowledge they gave us was forgotten and rediscovered again by others after them. So, settled with Pathfinders because someone in America had written a book called The House of Wisdom. But then my book comes out in America with the title. So Penguin US clearly weren't as worried as Penguin UK. But there we go, The House of Wisdom. Okay, as I mentioned, I was born in Baghdad in a district called Karadis Maryam, on the river Tigris, stone's throw away from the US-controlled Green Zone. I grew up in Iraq, and I left in the late 70s when Saddam came to power. And I came to Britain, did my A-levels, went to university, and followed a career in academic science. And it was really only in recent years that I felt that cultural tug to somehow rediscover for myself what is my cultural heritage on my father's side, and then realize that this was a great story to tell. I was born in Baghdad, as was one of the great characters of the Abbasid dynasty. Now, the Abbasid dynasty was the second great dynasty of Islam after the Umayyads, who were based in Damascus. That was their capital. The Abbasids built this new capital city of Baghdad in 762 AD. So they built this round city on the river Tigris in a region in central Mesopotamia where there were lots of market towns and villages. It was a very fertile region. It was a nice spot to build their new city. Now, nothing remains of that original walled round city, which was just a few miles in circumference. In fact, if we overlay that on modern Baghdad, you can see it's smaller in area than the Green Zone. I might say something about just how large the Green Zone is, I guess. I was born, we had a house somewhere up there. So the ancient city of Baghdad in Abbasid times, there's very little that remains of that city archaeologically. But actually Baghdad very quickly grew to become what many historians regard as the largest city in the world at the time. In fact, and of course it's very difficult to get reliable figures, but there are historians who say it was the first city to have over 1 million population. It was certainly far greater than the other big cities of the ancient world, Constantinople, Rome, Athens, Damascus. It reached its zenith, its golden age, during the time of a particular Abbasid caliph by the name of Harun al-Rashid. Now, Harun al-Rashid is famous even in Western culture because he's a character who appears regularly in the 1001 Nights. A lot of the stories in the Arabian Nights, 1001 Nights, involve the Caliph, Harun al-Rashid, walking around the streets of Baghdad and meeting people. And this oil painting is a 19th century painting depicting Harun al-Rashid receiving his counterpart, King Charlemagne, who was the great power in Europe at the time. And historians write that King Charlemagne was in awe of the opulence and grandeur of Baghdad. There was nothing in Europe to compete with it at the time. Harun al-Rashid, so that was the period when the Islamic Empire was really at its most glorious and largest. So it stretched from India in the east through to Spain, Andalusia in the west. It was larger even than the Roman Empire at its greatest in terms of area. But it was Harun al-Rashid's son, the Caliph al-Ma'mun, who really kick-started what historians now refer to as the golden age of Arabic science. Al-Ma'mun, it is said, created this new academy, the House of Wisdom, Bayt al-Hikmah. Some historians argue that since there's no evidence of this as a physical building, they contest what its purpose was. Some say it was nothing more than a library. Others say it was just a translation house. Others say it was very much like the Library of Alexandria, where some of the greatest scholars of the time would congregate and discuss matters of science, astronomy and philosophy and mathematics and medicine and so on. What is not in doubt is that Baghdad at that time was the place to go if you wanted to make a name for yourself in scholarship. In the same way that these days, you know, the very greatest scholars want to go either to Oxford or Cambridge in the UK or Harvard or Yale in the US. In Baghdad, that was the place to be. What kick-started the Golden Age was a period of wonderful translation. Al-Ma'mun, the Caliph Al-Ma'mun, this would have been in the early 9th century, was obsessed with books. Now, the Abbasid dynasty in general were obsessed with scholarship and learning. That wasn't something they particularly had as part of their culture, as part of the new religion of Islam that had come out of Arabia. To a large extent, it was their connection and close association with the Persian Empire, the Sasanian Empire. The Persians were very interested in scholarship and learning, and the Abbasids sort of affiliated themselves a lot with a lot of the custom and culture of the Persians. I'll say a little bit more about what the religion of Islam did to help push science forward at the time, which may seem somewhat maybe unexpected to many people. But there was this obsession with translation and with patronage of scholars. The Islamic Empire at the time was very, very wealthy. It was very rich, it was very powerful. Its borders were expanding, it was getting taxes from the nations that it conquered. But you need wealth to have the luxury of patronage of scholars. In the same way that, you know, the Renaissance began with the wealth of the Medicis, providing the means for people like Da Vinci and Michelangelo and art to flourish in Florence. There were scholars in that part of the world, what we now refer to as the Middle East, Christian, Jewish scholars who were aware of the great work of the Greeks. So the works of Aristotle and Plato, the medical texts of Galen and Hippocrates, the astronomy of Ptolemy, the mathematics, the geometry of Euclid. And there were translations of some of these texts into the languages of the region, like Syriac. With the spread of the new religion, and the holy book of the Quran, which was written in Arabic, Arabic became the official language of the empire. So even those who were not native Arabic speakers, in particular, for instance, the Persians, they had to be able to read Arabic, to read the holy book. And so all text became, there was a need to have text translated into Arabic. And that's what people like Al-Ma'mun did. They would pay translators to translate the works of the Greeks into Arabic, either from Greek or from Syriac or from Sanskrit or Pahlavi or whatever the language that was translated in, to build up this corpus of texts on all subjects of science and scholarship in Arabic. This translation movement went on for a couple of centuries. Very often, the most important books, like Ptolemy's Almagest, the great text on astronomy, that would have been translated 2, 3, 4 times by different people as they translated in Arabic, as they then began to develop their own scientific work and understand and reinterpret the Greek text. They would improve on them. It's the translation movement that then allowed a golden age of original science to flourish. There were many great names around at the time in 9th century Baghdad. I'll just list 4 or 5 of them. Jabir ibn Hayyan. Now, he was basically around at the very beginning. He was almost the first scholar of the Islamic Empire. In fact, he didn't even live in Baghdad. He lived in the city of Kufa, just south of Baghdad. He's regarded as the first chemist. Now, in a sense, you could say, well, how much of what he was doing was really science? How much of it was chemistry, and how much of it was alchemy? But of course, the distinction between chemistry as a proper scientific discipline and alchemy, which is wrapped up in mysticism and superstition, has only been differentiated in the last few hundred years. The word chemistry in Arabic is alchemia. Alchemia is what gives us the word alchemy. So until about the 17th century, even in English and Latin, there was no distinction between chemistry and alchemy. They meant the same thing, and they were interwoven together. What Jabir ibn Hayyan did, although he had some pretty weird ideas, wonderful ideas about raising the dead and men who could fly, anyway, it's very, very strange magic, and he was very protective of a lot of his ideas. So much so that he would deliberately write as obscurely as possible. So obscure was his writing that the word gibberish has its origins in Jabir, writing like gibber, which was the way it was pronounced. I kid you not. So, although it was very obscure, and although a lot of it was wrapped up in superstition and alchemy, nevertheless, he was a very careful, quantitative scientist. He would measure, he would study, he would synthesize. A lot of the techniques that even today are basic techniques in a chemistry lab were developed back around that time. And historians are still arguing today as to whether he synthesized certain acids and alkalis. Alkali, by the way, another Arabic word. In fact, a lot of words like alcohol and alkali are Arabic in origin. You can tell from the prefix el, meaning the. Hunayn ibn Ishaq, he was a Christian physician. He was the greatest translator of this wonderful golden age of translation. For almost half a century, he was in particular paid by a group of brothers called the Banu Musa brothers, who paid him to translate a lot of the, in particular, the medical texts of Galen, the great Greek physician. But Hunayn ibn Ishaq was also a polymath, and he was interested in mathematics, he was interested in astronomy, as well as medicine. But I list him as an example that you know, calling this Islamic science would be very wrong, given that there were very important scholars of that period who didn't convert to Islam. Al-Kindi was the greatest of all Arab philosophers. Now, I wouldn't claim that he's the greatest of all philosophers of that period. There were greater philosophers than him, but they weren't Arabs. Avicenna, Ibn Sina, for instance, who was Persian. But Al-Kindi was the first person to synthesize and explain and bring Greek philosophy to the masses. He was the first person to try and bring Greek Aristotelian philosophy together with Islamic theology to see if they could be grafted together to make sense. And a lot of his work was then the inspiration for many later philosophers. Al-Khwarizmi, I will talk about him in a moment. He is one of the greatest mathematicians of all time. He was certainly one of the greatest mathematicians of the medieval world and the father of algebra. And I will expand upon that in a moment. Al-Razi, Rhazes in Latin, was a great physician. Attributed to him are the very first hospitals in terms of how we would define a hospital today, as a place for many physicians to work together, where the sick would be kept under supervision, where they would dispense medicines and so on. So how we would define a hospital today, we see the very first hospitals in Persia and what is today Iraq, certainly in Baghdad, and they were initiated by projects that Al-Razi oversaw. Okay. Oops, the battery's died. I have to lean over and do this. Oh no, that's because the whole thing is... my whole laptop has died. Here we go. Okay. Al-Khwarizmi, so clearly you can all read that on the left. I won't go through it. Al-Khwarizmi is regarded as the father of algebra. Now, I don't know how much algebra you remember from school days, but it's the equations with the unknown x and y, and you solve them to solve many problems in mathematics. Many people will say, well, they're very pleased not to have to do algebra anymore, very pleased when they stopped having to learn about it at school, but it's one of the most important fields of mathematics. Now, the Greeks were very good at geometry. They're very good at numbers, number theory, arithmetic. But algebra really owes its existence to, essentially, this man, this Persian mathematician. There were Greeks who were solving equations that we might think of as algebraic equations. In particular, there's a Greek mathematician by the name of Diophantus, who wrote a book called the Arithmetica. But what he was really doing is number theory. He wasn't doing proper algebra. Even the Babylonians actually were solving what are called quadratic equations, equations involving x to the x squared. But they were solving these equations for particular problems. Al-Khwarizmi was the first mathematician to generalize the techniques of algebra. He wrote his book, which has a long title, but the shortened title is Kitab al-Jabr, the Book of Completion. Al-Jabr, completion. Al-Jabr is the word that we use for algebra. So his title of his book gives us the name for this field of mathematics. That in itself, of course, is no reason to credit him with being the father of the new field. What he does in this book, though, is give us the recipe for solving algebraic equations. What he gives us is what we call the algorithm. Algorithm comes from the Latinized version of his name, Algorithmus. So his name gives us the word algorithm, and the title of his book gives us algebra. What he does is explain how to solve equations. His book is wonderful because, well, actually, unusually, this is a textbook on mathematics, and it contains not a single equation. It's written entirely in prose. So he says, you know, X is the unknown. He calls it al-shay, the thing. You take al-shay and you multiply it by itself, then you add to it 3 times the shay, and then the answer is 10. Here is how you work out what al-shay is. And he goes through, in prose, explaining how to solve this quadratic equation. What he does that's new and original, that no other mathematician had done before, was for him that the unknown, x, isn't just a symbol hiding behind which is a particular number. It exists, x, the unknown, exists in its own right. And you manipulate the equation. The book of completion involves the manipulation. You take things from one side of the equation to the other. He describes all of that, and then the last line is therefore x equals 3 or whatever. Only then does x take on a value. So he gives this general way of solving equations. That hadn't been done before, and it's only after that that this new field of algebra really emerges. It is probably the most sort of high-profile piece of original science that the medieval Islamic world has given the rest of the world. I have to always be careful when I promote some of the many wonderful ideas and original discoveries in science that were developed at this time, not to over-egg things. I'm always reminded of that sitcom, Goodness Gracious Me, with the elderly Indian gentleman who regards everything as having been invented by Indians. Television, Indian. Computer, Indian. I don't want to give the impression that somehow everything, all our knowledge of the world around us, we owe to these scholars in this period, in this part of the world. But credit where it's due, and where there are original ideas such as algebra, then I will mention them. One of the myths, for instance, is that the Arabic world gave us 0. Well, in terms of the word, certainly cipher, the word cipher comes from the Arabic sufr, which means 0. But actually 0 wasn't invented in the Islamic world. And in fact, when we talk about 0, we have to be quite careful what we mean by 0. It gets quite subtle. Do I mean 0 as a placeholder, a symbol that I can write down in a number so I can tell the difference between 11 and 101? You know, I put a symbol between the two ones. Do I mean 0 as a concept? Or do I mean 0 as a number that sits halfway between +1 and -1 that I can use to do in my arithmetic? 0 as a symbol goes back to the Babylonians. And actually, soon after that, the Mayans in Central America. So this is about 300 BC. 0 as a concept, nothingness, the vacuum, well, that we have Aristotle to thank for. So 0 as a philosophical concept goes back to the time of Aristotle. Again, round about 300 BC. 0 as a number goes back to the Indians. The Indian Hindi numbers, the decimal system, was inherited by the Islamic world after it had been developed in India over several hundred years, and that package of the decimal numbers 1 to 9 plus the 0 came all in one lump. Now, of course, the Arabic scholars didn't take up the decimal system very quickly, nor, of course, did the Europeans. It took some time, some centuries, before it embedded itself. But we refer to, as another bit of Arabic text, we refer to the numerals, the decimal system that we use today, as Hindu Arabic numerals. The scholars, the mathematicians of the Islamic world, who wrote their texts in Arabic, did contribute. What they contributed, in fact, was the decimal point. Until then, people didn't use decimals, it was all fractions. This is a page from an 11th century scholar by the name of Al-Uqlidisi, which means the Euclidean. His job was to translate and interpret the mathematics of Euclid, Euclid's book on geometry, the elements. But he was also a mathematician, a very competent mathematician in his own right. Let me show you, let's see if we can make this make sense. So you can see, I'm going to zoom in, this number here, 179685 in Arabic way of writing it, and there's that dash over the 9. Okay, so that number is 179.685. That dash he used to refer to a decimal point. What he was doing was showing that there were certain arithmetical operations where it was much more useful and sensible to use decimals rather than fractions. So, for the mathematicians in the audience, this is what he was working out. He said if you take a number, and x, and in this case actually x was 135, but it was just, doesn't matter what it is. But he said if you take a number and you add to it its 10th, x plus x over 10, and then take that answer and add to it its 10th, and so on. Do it 3 times. You end up with a rather neat little expression, x times 11 over 10 cubed. Right, he said, well, that number, try and work it out as a fraction. Not very nice, very messy. A much neater way of writing that number is to write it as a fraction, and that's what he gets. So that is, as far as we know, the first time we see someone use the decimal point. It may have been used and discovered in China. It may have even been around before them, but we don't know enough about Chinese mathematics at the time to be able to say whether they came up with the decimal point before someone like Al-Khalili. Okay, I'm a physicist, and so I want to tell you a little bit about my favourite physicist of this period. Archimedes is, I guess, the great physicist of the ancient Greeks. Isaac Newton, the greatest physicist, the greatest scientist probably who ever lived. There's a span of 2,000 years between these two great physicists, and so the question is, who is the greatest physicist between Archimedes and Newton? Bear in mind there's some pretty impressive people like Galileo in there. I would argue it's this guy, Ibn al-Haytham. His Latinized name is Al-Hazim. A lot of his work was translated into Latin and was known by European scholars, but to a large extent he's been forgotten around the world today. He was a very colourful character, so he spanned the 10th and 11th centuries, so 1,000 years ago. I'd say just spend a couple of minutes saying something about his life, because he's such a wonderful personality. He was born in the southern Iraqi city of Basra. His parents were both diplomats, worked sort of in the administrative role there in Basra, and he was given some administrative role which he didn't enjoy. He really wanted to pursue his thirst for knowledge and learn all about astronomy and the work of Ptolemy. But of course, he wasn't able to do that because he was constrained by this really boring job. So what does he do? He feigns madness. He pretends that he's mad, and he gets sacked from his job, allowing him to pursue science. And from then on, he's happy. He discovers that there's a new dynasty has just taken over in Egypt. It's called the Fatimids. And the Fatimids build their new capital, Cairo. He writes to the Caliph in Cairo and says, I know that you have problems with the flooding of the Nile and regulating it for irrigation purposes. I've got a really good idea. What you want to do is build a dam across the Nile, round about where, in the south, where the modern-day city of Aswan is. The Caliph invites him over to Egypt, and he goes. It's not clear. There are various historical accounts, but it's not clear whether the Caliph accompanies him on his trip down from Cairo down to the south or not. But anyway, he gets there and realizes that actually, as an engineering project, he's bitten off much more than he can chew. He doesn't really think he can build this dam across the Nile. And he's also aware that the Caliph, Al-Hakim, is also known as the Mad Caliph. So it's not going to go down well when he tells him, sorry, I don't think I can do it. So what does he do? He feigns madness. And he saves his neck, but he's put under house arrest in Cairo for a number of years until the Caliph dies. It's during that time when he's under house arrest, and it's not clear whether he was living in a room in the Al-Azhar Mosque in Cairo or somewhere nearby. But what is known is that it's during that period that he writes his greatest works in mathematics and astronomy. He writes his Book of Optics, which is every bit as important historically as Isaac Newton's Book of Optics 700 years later. See, we learn at school that Isaac Newton's the guy who you know, prisms and mirrors and angles of incidence and reflection and the splitting of white light into the colours of the spectrum. A lot of optics goes all the way back to the ancient Greeks, people like Plato and Euclid. Ibn al-Haytham's book on optics was tremendously important and influential. To begin with, he elaborates and explains correctly how we see objects. The Greeks couldn't agree on whether, when you see something, light from the object comes into your eye, intromission, or whether by looking at something you shine light on it, extramission, which is, you know, like Superman. And they were divided. So people like Euclid and Plato thought that you saw things by shining light on objects. They say, how else can you pick out detail? How else can you see the needle in the haystack if not by shining light directly on it? If light is coming at you from everything, how do you discriminate between all the objects that you see? And they developed a very sophisticated mathematical, you know, geometrical ideas about how light shines from your eyes onto objects. In contrast, other Greek scholars like Aristotle said, no, light enters your eye. But Aristotle was more of a philosopher than a mathematician. So he didn't use all the tools of geometry to try and describe his theory. Ibn al-Haytham comes along and says, Aristotle is right in that light, we see things because light enters our eye, but he makes use of the ray diagrams and the geometry that were developed by people like Euclid and Plato. So he talks about light traveling in straight lines, he talks about angles of incidence and reflection and refraction, the bending of light as it passes from one medium to the other, from air to water, for instance. He also explains the notion of perspective. Further objects look smaller. That work was particularly important for many Renaissance artists in Florence. In fact, his work, together with the work of others, became a very important book in Latin called De Perspectiva, which was used, so the Latin translation of his optics was used by many Renaissance artists in understanding the notion of perspective. So Ibn al-Haytham also wrote on astronomy and other areas of mathematics. There's a famous puzzle in mathematics called, I don't think I have it, no, I didn't include it here, called Al-Hazin's problem, which is to do with bouncing light off a curved mirror. It's easy when you bounce light off a flat mirror because the angle of incidence, the angle of reflection are the same. So you know if you bounce it off a certain point, you know it's where it's going to end up. But if the mirror is curved like the inside of a circle, then it's very difficult to work out where the light will bounce off. It's actually a difficult mathematical problem that wasn't solved exactly until about 10-15 years ago by a mathematician in Oxford. But Ibn al-Haytham provides a geometric way of solving it, which is a sort of a good, sort of rough and ready way of doing it. And so for the last 1,000 years, it's being referred to as Al-Hazin's problem. His work inspired a number of other scholars. In fact, at the same time as him was another physicist by the name of Ibn Sahel, who is not very well known at all, but work of his was discovered not that long ago by historians of science that show that, in fact, I don't know how many of you, if you remember Snell's law of refraction, which tells you if you have light falling from air onto water, the reason why a swimming pool looks shallower than it really is, or the reason why a spoon looks bent in a glass of water, is because light gets bent as it travels from one medium to the other. It's because light travels at different speeds. It slows down when it enters the water. The way you work out how much it bends is referred to as Snell's law. Actually, 600 years before Snell, a European mathematician, came up with it, it's now discovered that Ibn Sahel, in fact, came up with the right answer. I've got a bad knee, so sorry. But I think it's probably for the mathematicians, just in case you're interested. The way he explains it, see, the Greeks thought that so this is the light beam coming, it's not very in focus, but that's fine. Light beam comes in this direction, this is air, this is water, and as it hits the water, it bends towards the vertical. The Greeks thought that if you divide that angle by that angle, you get a constant number. In fact, we know that it's to do with trigonometry, to do with sines. So the sine of this angle divided by the sine of this angle is in fact the constant. Well, Ibn Sahel was the first person to actually give that correctly, because he said what the Greeks were doing were dividing the length of that arc by the length of that arc, which is equivalent to dividing the angles. What you should do, he said, is divide the length of this half chord by this straight line by this straight line, which is exactly what Snell explained 600 years later. Now, I'm not proposing that Snell's law in all textbooks around the world should be changed to Ibn Sahel's law. It's just that here's another example of a pathfinder. That as we uncover some of this work, you realise that many of these ideas were hit upon a lot earlier. And I'm not suggesting that Snell, for instance, was aware of Ibn Sahel's work. He just hit upon it a second time, much later. Al-Biruni, another one of my favourite scholars. Of course, there was no portraiture back in that time, so I've no idea what he looks like, but I could be mean and say, well, he probably had a beard and probably wore a turban, and so you can so his contemporary, I'll mention something about in a minute. Ibn Sina was a bit more suave and sophisticated, a bit of a dude. So they probably draw his beard, a bit trendier. But we don't know. Biruni, however, was a polymath. Now, Biruni is not so well known. He was a Persian scholar. He travelled around Central Asia, contemporary of Ibn al-Haytham's, and I do really regard him as the Da Vinci of the medieval world. There's hardly any discipline in human knowledge that he hasn't made some contribution to. He wrote on history, geography, geology, mathematics, astronomy. He helped develop trigonometry. He was a physicist, a philosopher. And he wrote a lot of these texts, but the reason he's not so well known is because, for whatever reason, his work never got translated into Latin. There are many lesser scholars who are well known in the West because their work was picked up during the Renaissance and were translated into Latin, but really their contribution to science wasn't anything like Biruni's. I'll just mention one of the nicest things that he discovered is that he was able to calculate the circumference of the Earth very, very accurately. Now, the notion that we thought the world was flat until Christopher Columbus sailed round is nonsense. The ancient Greeks knew the world was round. They could tell from a ship coming over the horizon that the surface of the sea was curved round. The ancient Greeks calculated the circumference of the Earth. There were one in particular who worked in Alexandria by the name of Eratosthenes. Came up with a crude way of calculating the circumference of the Earth by looking at the angle that the sun made and then counting paces over many miles, many days, until the angle of the sun at the same time of the day had changed by 1 degree. He said, well, if this many paces, this distance, gives me a change of the sun's angle of 1 degree, how far would I have to walk to give me 360 degrees? That would mean going all the way around the Earth, which is actually fine, it's correct. And the ancient Greeks did know roughly the size of the Earth. Biruni says, I've got a better way of working out the size of the Earth that's far more reliable than counting paces and traipsing across the desert, which is, you know, you're just going to lose count, surely. Eratosthenes' method, in fact, involved measuring the distance between Alexandria and Aswan in Egypt. Now, it's very difficult to know how they could have travelled in a straight line without following the meandering path of the Nile. It's also very difficult to know how reliable. You know, I'm sure it wasn't him who counted paces. He got someone to do it for him. And we don't know their units of measurement, what are called the stadia, the lengths that were used by the Greeks and how they connect to the modern day mile or kilometre. Biruni does it using a clever trick in geometry. What he first does is measure the height of a mountain. I won't go into the details of the geometry. Basically, he has this device. It's a bit like a modern theodolite that architects and surveyors use. But he can, by just clever use of triangles and line of sight, he can work out the height of a mountain. So that jagged line is meant to be the side of the mountain. He then climbs up to the top of the mountain, knowing how high it is. I've exaggerated the height of the mountain compared with the surface of the Earth, of course. And he does a bit of trigonometry. He says, if I stand at the top of the mountain, and he's got a plumb line and a astrolabe to measure angles, and he measures the angle of inclination to the horizon. So he needs a mountain that overlooks either a sea or a flat plain. In his case, he found a flat plain in central Pakistan, and measures the angle to the horizon and how much of a dip that is from the horizontal. That is the angle that I've symbolised there with the Greek letter phi. Using that knowledge and the knowledge of the height of the mountain, he can rearrange things and work out the radius of the Earth. He then multiplies the radius by 2 pi. As you remember, the circumference is 2 pi, the radius. And he comes to an answer, which is about 25,000 miles, which is within 1% of the modern day value for the circumference of the Earth. Bearing in mind, of course, that the Earth has slightly greater circumference around the equator than it has around the poles. Nevertheless, it's incredibly accurate. But more than that, it's just such an elegant solution to work out the size of the Earth by climbing up a mountain and looking at the horizon. Absolutely ingenious. I want to say a little bit about other areas of knowledge and science. Many Islamic scholars were very good map makers. They'd inherited a map of the Earth, a map of the world, produced by the Greek astronomer Ptolemy. But of course, they had to revise it and improve it. For instance, Ptolemy's map didn't have Baghdad or Mecca, two of the most important cities in the Islamic Empire. And so they had to redraw and expand on the map. Now, this looks like a particularly silly-looking map. It doesn't look like anything, really, until you remember that back then, north was at the bottom of the page and south was at the top. So we need to do this. Suddenly you recognize it. You recognize the Mediterranean, the Arabian Peninsula, and so on. Al-Idrisi was an Andalusian scholar in Spain who went and settled in Sicily and produced this new map of the world there. But there were many map drawers in the Islamic Empire right from the very beginning of Islam. Let me say at this point what the religion of Islam had to offer and why this golden age began at that point. Well, I mentioned the most important, actually, at that point, which was the Islamic Empire was very rich and powerful, and it had the luxury of being able to build these grand academies and provide the patronage and the financing of the scholars and the translators and so But also work, for instance, in geography required developing what's called spherical geometry. So not the geometry of flat surfaces, but curved surfaces, because they needed to know, for instance, what direction to face to pray towards Mecca. That required quite sophisticated geometry if you were, depending on where you were in this vast Islamic empire. It's different if you only lived in the Arabian Peninsula and you sort of know, where east and west is and where Mecca's in that direction, fine. But what if you lived in Andalusia? What if you lived in Pakistan? What if you lived in Morocco? So that required developing geometry, knowing when to fast during Ramadan, knowing when to pray, so knowing the motion of the moon, required developing ideas in astronomy that had to be more accurate than anything the Greeks had done. And that's where we see, in particular in astronomy, I'll say something about astronomy in a moment, what their advances were. Not so much that they overthrew Greek astronomy, but they simply did their measurements better and more carefully and more accurately. Likewise, the new religion of Islam then was very clear in that it preached that scholars should go and seek knowledge wherever they could find it, even if they had to go as far as China. The idea being that although here is our holy book, the Quran, go and learn about God's creation and then come back and better interpret these words, which is in absolute contrast to many Muslims in the world today who shun science as being un-Islamic, that somehow science is a Western atheist construct that they're very suspicious of. And I get very frustrated and sad when I receive letters or emails from someone saying, the Big Bang, quantum physics, relativity theory, it's all in the Quran, And, I remember I made a series about science in the Islamic period called Science in Islam a few years ago, and I travelled to the Middle East, I went to Iran, and I even went to religious schools, madrasas there, where I spoke to holy men, and they were quite adamant that this was silly. They said, well, the Quran is simply, it's a book that tells 1 billion people how to live their lives. Now, for me, I'm not religious, but if that's what tells them how to live their lives, there are things that I would agree and things that I would disagree with. But it's not a book on mathematics. It's not a medical textbook. It's not a book on astronomy. And so there's a contrast between how science and rationality and free thinking was allowed 1,000 years ago, compared with how it's viewed in many parts of the Islamic world today. So that was a sort of a slight aside that this new religion of Islam, together with the Persian obsession with scholarship and learning, helped boost and kickstart this golden age. I want to move on very quickly and just say a little bit more, and then I want to stop in about five or 10 minutes. Ibn Sina, Avicenna, is the most famous of all the scholars of the Islamic Empire. Avicenna is his Latinized name. Ibn Sina is his original Persian name. Like Biruni, he was a Persian. He didn't like writing his texts in Arabic, but he knew if he wanted to get his work publicized, he had to. He was a great philosopher. In fact, before him, the greatest philosopher, greatest thinker was Aristotle. Avicenna, Ibn Sina comes along, and he now, almost in some sense, certainly for many hundreds of years, replaces Aristotle as, the font of wisdom when it comes to philosophy, the last word on philosophy. He synthesizes, like no one has done before, Greek philosophy of Aristotle and Plato with Islamic theology. Those ideas, that way of synthesizing Greek philosophy with theology, was taken up by the Jewish scholar Maimonides, who started work in Andalusia but then went and settled in Egypt. And in the Christian world, people like Roger Bacon and Thomas Aquinas were very familiar with Avicenna's work, the Latin translations of Avicenna's work. He also wrote what was probably one of the most important medical textbooks in history. Certainly the most influential since the work of Galen in ancient Greece. Avicenna's Canon of Medicine became the recommended textbook, well, it's a group of textbooks on medicine for something like 6 or 7 centuries. Imagine now, I mean, when I recommend textbooks to my students and they say, oh yeah, but that's 1960, surely that's out of date now, you want something more modern. Imagine for 600-700 years, anyone, anywhere in the world, you go to the libraries of Paris of the 16th or 17th century and there will be Avicenna's Canon of Medicine. And it talked about anatomy, it talked about disease in many volumes. And it wasn't really until the birth of the scientific revolution in Europe that you get physicians and anatomists taking the work a lot further than Avicenna. Okay, Andalusia in Spain was also a hotbed of work, and I mentioned there's the great philosopher, maybe I didn't mention him, Averroes, who worked in Andalusia. There was also a wonderful surgeon by the name of Zahrawi, who was credited with inventing all sorts of medical instruments. And Zahrawi is credited with inventing the forceps, the syringe, catgut used for surgery, even early techniques in what's it called? Anesthetists. And anesthetics is the word I'm thinking of as a... Thank you. It's okay. So, I don't want this to turn into a list of all these the things that have been done. So I think I'll skip through the next one. Let me just say something about astronomy, and I'll end on astronomy. The astronomers of the Islamic period really didn't, in a sense, didn't go that much beyond the ancient Greeks, because like the Greeks, they didn't have telescopes. So everything they learnt about the night sky, they had to do with the naked eye. They had all sorts of instruments. They had armillary spheres and astrolabes, ways of measuring, tracking the motion of the heavenly bodies in the sky. The one thing that they weren't able to shake off was the idea that the Earth is at the center. So this is Ptolemy's Almagest. Ptolemy has the Earth at the center of the universe. And when you look at planets orbiting around, because the Earth goes around the sun like Mars goes around the sun, when we look at the orbits of other planets, you see them carrying out this retrograde motion. So Ptolemy had developed this rather sophisticated theory of his geocentric model of the universe, which got ever more complicated depending on what sort of objects you're looking at. Because the moon is easy, the moon really does go around the Earth. The sun is not that difficult because, the Earth goes around the sun, but the sun's big enough to just behave itself. But if you're tracking the other planets that also go around the sun, things get complicated. They even had to move the Earth away from the center of the cycle. There's the epicycles and the equant and so on, and center of deference. It all get very complicated because the Greeks insisted that the Earth was at the center of the universe. And the Islamic astronomers followed suit. They thought that as well. And of course that didn't change until the scientific revolution in Europe, and Galileo and Copernicus. Well, what was happening at this time in Europe? I've mentioned all these scholars, and I've said at the beginning that Europe was in the Dark Ages. Were there any sort of bright lights at the time? Well, there were a few. I'll mention just a few names. So this is after the fall of the Roman Empire in the 5th century. There weren't that many names in Western Europe, certainly, that are worth noting. Abelard of Bath was probably the first English scientist. He travelled in the 11th century, 12th century. He travelled to the Middle East. He learnt Arabic, and he translated a lot of the Arabic texts into Latin. Similarly, the The Italian mathematician Leonardo of Pisa, better known as Fibonacci, also learnt Arabic. He went to the Middle East. He was the first person to translate Al-Khwarizmi's book on algebra into Latin and bring it back to Europe. There were other scholars, Thomas Aquinas, William of Ockham, who really were working in isolation compared with this, hubbub of activity in the Islamic world in cities like Baghdad and Cairo and Damascus and Cordoba. But of course then the Renaissance arrives, and it's at that point that we start to see a big decline in the activity in the Islamic world, mostly because it's taken in contrast with the rapid rise of scholarship in Europe. Copernicus is the first person to clarify that in fact the Earth isn't at the centre of the universe. The Earth is just a planet going around the sun. That is then confirmed by Galileo with the invention of the telescope. So this is a page from Copernicus's book, De Revolutionibus, where he has very clearly Sol, the sun in the middle, and then Mercury, Venus, Earth, Terra, with the moon going around it. So, in a sense, we say we can sort of almost disregard all the astronomy that came before Copernicus, because they all had this muddled way of thinking that the Earth was at the centre of the universe. So let me just say a couple of things. First of all, Copernicus wasn't the first person to propose what's called the heliocentric model. There were many scholars going all the way back to ancient Greece who suggested that, in fact, the Earth goes round the sun, not the other way around. There was a Greek by the name of Aristarchus who had proposed this. No one believed him. There was one Babylonian astronomer, Seleucus, who was a fan. He was sort of almost, that his hero worshipped Aristarchus, and he tried to promote his ideas. But most ancient Greeks thought Aristarchus was talking nonsense. How can you say that the Earth goes round the sun? Similarly, there were Indian astronomers, there were astronomers in the medieval Islamic period who had proposed that the Earth goes round the sun. What Copernicus did that was different to all of them was that he put it in a proper scientific theory. But even Copernicus was only guessing, because Copernicus didn't have any telescopes. He predates the telescope by a few decades. And so when he says the Earth goes around the sun, he's sort of, it makes sense to him, but it's not confirmed scientifically. And the mathematics he uses turns out to also make use of a lot of tricks that were developed in the Islamic Empire. So I don't really have time to go into it, but there's another Persian astronomer by the name of Tusi who worked in Persia. In fact, he lived for many years up in the mountains in northwest Iran, among a group of a sect of Muslims known as the Hashashin, where the word hashish comes from. But it's not because they grew marijuana. It's because hashish, the grasslands around that area. But actually, Hashashin is where the word assassins comes from. They became the assassins. This group, decades later, were used to sort of bump people off who were undesirable politically. Tusi, anyway, I'm completely digressing. Tusi was this wonderful mathematical astronomer who developed these mathematical techniques, whose work was then translated into Latin and found its way to Italy, and found its way to people like Copernicus, who made use of them. And as historians of science now know, it's more than just the evidence is very strong that Copernicus must have known about Tusi. Copernicus does refer to and acknowledge a number of astronomers from the Islamic world, in particular a Syrian astronomer by the name of Battani. But he doesn't really acknowledge Tusi. But we now see that the techniques Copernicus used were developed by this Persian astronomer many centuries earlier. Galileo, of course, is really the father of modern astronomy because the telescope arrives. Now, I really have to end, and I just want to end then on this lovely picture, which is the frontispiece of a book by an astronomer by the name of Hevelius, who was the first person to really study the surface of the moon using a telescope. And on the front of his book, he puts the two scientists who he regards as the real giants of astronomy. The experimentalist, Galileo, on the right with his telescope, and the theoretician, Ibn al-Haytham, on the left with his piece of paper and drawings of geometry on it. So certainly by the sort of the mid-17th century, at that point, people like Ibn al-Haytham are acknowledged and regarded as being owed a debt of gratitude because of the work that they did in developing science. And what is a tragedy is that today many of these names, Biruni, Ibn al-Haytham, Tusi, even Al-Khwarizmi, who developed algebra, are lost in the mists of the past. And even what's sad is even in the Islamic world, many of these names, they may have heard about them, but they will have heard about them in history lessons, not in science lessons. These guys are as important as Einstein and Newton and Galileo, Aristotle, Plato. I don't want to make comparisons about who was greater and who should be credited with what. But the point is that science develops as a continuum. Civilizations rise and fall. But science as a body, texts are translated, are preserved, are advanced upon, are developed, and science and our body of knowledge of the world around us develops. And what will be nice is to acknowledge that there is this gap in the history of science that is filled with some of the work of these Islamic scholars. And I should end there. Thank you very much for your attention.
Thank you very much, Jim. I'm sure we all agree that to those names like Archimedes and Aristotle and Galileo and Newton, which we rightly consider to be the shared heritage of all humankind, we should certainly add some of the names that you introduced us to this evening. There are two things I forgot to say. One is that if you are tweeting, it's a bit late now, but if you were to tweet, how lovely the lecture was, you should use the hashtag Holyoake, Holyoake.
There's some puzzled faces out there.
Yes. And if you don't tweet,
hashtag?
Don't worry. And if we should catch on fire, again, it's a little bit
rather
too
late now.
Please leave the building. This door. The British Humanist Association, as I said at the beginning, is very happy to host this lecture. This is a short commercial break. For those of you who are not members or supporters of the British Humanist Association, there's a leaflet about it on your chairs. This event is also organised by the Greater Manchester Humanists, whose literature is also on your chairs when you came in. And at this point, I'm going to step down from here and hand over to Guy Otten from the Greater Manchester Humanists, who's going to lead the questions, for which we have a short amount of time, but which I'm sure you're all full of. So thank you very much, and Guy can come on.
That was for him, I hope. Yeah. I've still got these keys, so do bear those in mind. Now, we've got 2 roving mics, but 3 sections. So what I'm going to do is I'm going to take questions from one section at a time, and then I'll move to the next section. Is that okay? Now, where are the mics? At the back here. So we'll start with this. We've got a question at the back there. Naya, it is. Yep. Do you want to stand up? Yep. Yep. Okay.
Well, thank you very much indeed, sir. That was a phenomenal lecture, and it was very erudite. It was very lovely together.
Thank you.
I was saddened as well about the lack of knowledge of these polymaths, these Arab polymaths in the West. And I'm a cardiologist, and I was researching in the history of cardiology, and it came as a surprise to me that the father of circulatory physiology was Ibn al-Nafis, an Arab polymath born in Damascus, brought up in worked in Cairo, and he is really the father of circulatory physiology. And he was the
Yes.
about the circulation of the blood, and he said it goes from the right side to the left through the septum, and he was the one who said that it cannot get to the left ventricle except through the lungs.
Yes.
Pulmonary circulation and also coronary circulation.
I skipped over that slide, in fact, so apologies. But you're right, because certainly in the West, when general knowledge questions, trivial pursuit questions, who discovered blood circulation, we all say William Harvey. But yes, you're right. Ibn Nafis was the first person to say that the blood doesn't go from one side of the heart to the other; it's got to go the long way round.
I would just hope so that your work will remedy this gap that is there in knowledge of the great Arab science.
Well, thank you. I do my bit.
Anybody from another one from down here? Yes. Can we have a lady at the front here?
Oh.
Yes. Yes.
Can I ask, please, why was it that so much of the Arabic world was lost and not passed forward? Was it translation or other reasons?
Well, a lot of it wasn't, of course. There was a second translation movement, not quite as grand as the first, from Arabic to Latin. So there was sort of Greek to Arabic and then Arabic to Latin. Some of those texts translated to Latin were originally Greek, like the work of Euclid and Ptolemy and so on. Others were originally in Arabic. But certainly there were great centers of translation like Cordoba and Granada and Toledo. So a lot of it was transmitted back to Europe. And to some extent, it's forgotten. There's nothing insidious about it. But I mean, it's against, I guess, forgotten because the scientific revolution in Europe was so rapid and the advances made so great, the Newtons and Galileos and so on, that everything before it sort of recedes into less significance. But all of it wasn't translated. And, just in case anyone's going to ask me the question, I might as well answer it now, because I always get this question, so apologies to anyone who's now not going to ask it. Why did it go into decline? What happened? What went wrong? And of course, that always puzzles me, because no one says, the golden age of Athens, or Alexandria, what happened? Ancient Greeks were so clever. What went wrong? We don't ask that. But civilizations rise and fall. And as the Islamic empire fragmented, as different dynasties came along that were less interested in learning and more interested in protecting their borders, then there wasn't that spare money for patronage of scholarship. And in contrast with Europe, of course, Europe rises rapidly, the Islamic world sort of drops down slowly. But it wasn't because the Mongols sacked Baghdad. It wasn't because Islam as a religion became more orthodox and conservative. There were those who thought that people like Avicenna was being a bit too un-Islamic, in taking on Greek philosophy. But on the whole, there was a lot that was taken back to Europe and translated into Latin. But for whatever reason, we've forgotten the debt. We've forgotten the route that knowledge has taken through the Arab world and back to Europe.
On that question, there's an amazing book called The Closing of the Muslim Mind. Do you know?
No, I don't know.
Yeah, it basically addresses that question. Should we take two more questions from the bottom and then we'll go up to the galleries? Over here and then lady over here.
And there's a gentleman over there as well.
Right, well, I'll
yes, come back to them later, yeah.
Yes, the period that you've been talking about, which is the Dark Ages, I prefer to call it the bright Dark Ages, because there was a whole lot of developments going on in the rest of the
world.
Yeah, absolutely.
Now, however, in relation to why the legacy is not acknowledged, I think it's also to do with a lot of type of academic closed minds as well. Let's take this case that you just mentioned about the Tusi couple as an example. That's been known for some time. But this attempt at linking the Tusi couple with the Copernican revolution has never actually been significant. Now I've got a couple of points about specifically regarding the development of algebra and other things. I don't think I'll go into that in any great detail, but in a sense, I wouldn't think that Al-Khwarizmi was the founder of algebra.
Okay.
I think this is certainly, if you had sort of suggested people such as Diophantus and some of the Indian algebras, that would have been probably closer.
Okay,
Anyway, thank you very much.
Okay, thank you.
Thank you very much. This lady over here, and then we'll go up to the galleries.
Do we not have to thank the Arab astronomers for giving us a lot of the names of the stars that we have today?
Absolutely, yes. I often wonder how, especially because I teach about it in my lectures, how to pronounce the name of the star Betelgeuse. And it's actually from the Arabic Betelgeuse. So I try and, it would just sound so pretentious when I say, you know, the star Betelgeuse. But it's not Betelgeuse anyway. But yeah, I mean, if you think about the stars in the Big Dipper, the 7 stars, 5 of them I think have Arabic names. And Rigel, sometimes people pronounce it as Regal, but it's Rigel, which means leg. Yeah, so certainly. The naming of things, in a sense, I guess, is no big deal. Yes, we have them to thank for the names, but that's not the same as advancing understanding. But you're right, absolutely. A lot of stars are Arabic.
Thank you very much, sir. I'll come back to the floor, but we'll take 2 questions from each side. So, who's got the first question on this side, either? Yes, there's one down here. I don't know if you can get hold of the mic.
I'm talking to an interested artist and designer who studied science to A-level, but you talked a lot about polymaths.
Yeah.
We live in the age of specialists.
Yes.
Do we need more generalists today? Could we learn that from this?
I think it's very difficult to have the sort of generalist that we had back then. Certainly, even going back to the Renaissance, people like Da Vinci. Simply because the body of knowledge is so vast now. And in order to really understand anything new about the world, and we're talking about academic researchers discovering something new, whether in the arts or the sciences, humanities, you need to know so much before you can make an original contribution. But we are seeing, actually, advances in science in particular that are being made because people are coming in from other fields. My own personal new area of research is something called quantum biology, which is rather new and almost speculative, which the idea of quantum physics and quantum chemistry, how atoms behave, applying it in the life sciences is very new. But we're seeing those, people coming in from medicine and engineering or computer science and chemistry. That's where a lot of the big advances are happening now. So to a lesser extent, yes, interdisciplinarity is probably the right word rather than wanting more polymaths. We can't ever, I think, regain those sorts of polymaths who were real experts on such a wide range of subjects. Well, that was it. No one else in this? Come on, guys.
Well, come down to the over there. Oh, sorry.
Yes, there's a hand.
All right. Well, there's 2 up here. Right. Well, we'll take that one first.
There's a microphone already.
We'll come down to Behzad Vakufti here.
Hi. You mentioned this revolutionary understanding when we put it at the centre. It seems to me it must be about 100 years ago that we actually realised there was a universe beyond sort of our galaxy, and those things that were called starry nebulae were actually galaxies in their own right. I'm struggling to find out exactly when that was and who was responsible for it. Do you happen to know?
That would have been probably Edwin Hubble. Edwin Hubble was the first person to realise that not everything we see in the night sky is part of our own galaxy. So he was studying a particular star in the galaxy Andromeda, which is our neighbouring big galaxy. And it was thanks to work of other astronomers that he was able to find the particular type of star that you could reliably measure the distance to. There's something called a Cepheid variable. So it was Edwin Hubble in the 1920s who first realised that star wasn't in our galaxy. It was much, much further away. Therefore, there was other stuff beyond just our galaxy. So yeah, you're right, almost 100 years ago.
Thank you very much. There's a gentleman over here. The mic is coming. Thank you. It's on.
Just an observation, really.
it's not just Arab science that's been forgotten, it's science before the Greeks and the Romans. And thinking in medicine, we think of Hippocrates. Hippocrates actually copied Imhotep from Egypt. So it's not just in Arab science, it's all sorts of non-Western cultures we forget contributed.
And that's exactly how science developed. So we said the ancient Egyptians, you're right, the ancient Egyptians had developed medicine, which the Greeks inherited. The Babylonians developed ideas of mathematics and astronomy, which the Greeks inherited. So you're right, I mean, to a lesser extent, but bodies of knowledge builds upon what's come before. And you're right, it's that there are big gaps all the way back to antiquity. Ever since mankind has questioned the world, that's, you know, we have to trace science back as far back as them.
Thank you very much for the lecture. Born and bred Iranian, really enjoyed it. One question I have for you is
it seems to be intermittent.
one question I have for you in regards of these scientists, because I agree with you in terms of that they made a great contribution to human knowledge in a way, but they are kind of forgotten. And I, in a way, see...
Swap microphone.
I, in a way, see us as the people who are the people of the Middle East to be actually at fault for that, because all the Western scientists, all the Chinese scientists, all the other scientists, they have their own people who are basically looking after their heritage in a way. They want them to be recognized, and they make sure that they are being recognized. But in all regions, we, in a way, forgotten them. We don't really appreciate them. They have kind of a sense of nationalism. Some Persian says they were all Persians who were doing it. And then
That's right. Yes, that's right. Competition.
Yeah. What do you think can be done from our perspective to actually kind of make the people there?
No, you're right. I mean, it's allowing those people to have a sense of pride in their own heritage. Well, not wishing to embarrass him, but there's a gentleman sitting up there called Professor Salim Al-Hassani, who's an emeritus professor of engineering here at Manchester University, who has overseen an international exhibition called 1001 Inventions, which has travelled all around the world and has been, I know it's been in America, and I think Hillary Clinton was there to open it in America and so on. So initiatives like that, where you remind, I think Salim refers to the 1,000 years of amnesia, right? That's your phrase. And that's amnesia on the part of those in the Islamic world as well. So I think, for me, it was, I'm interested in science and interested in ideas and the history of ideas, and it's a great story, and there's some of these really colourful characters that I wanted to... I remember when my publishers said, when I started writing my book, they said, look, don't just give us a history of science, we want you to paint a picture of what the Abbasid world was like. What was 9th century Baghdad like? I'm not a historian, so it was a steep learning curve for me. But there's another reason for telling the story, which is exactly, as you say, to give a sense of pride for people in the Islamic world, and hopefully that would remind them that there was a time 1,000 years ago when rationalism was okay, when having an open mind and questioning was okay, as opposed to what you see so often now, which is the idea that science and rationalism and learning about the world is treated with suspicion and is treated as though it's something that's anti-Islamic. So maybe reminding them that their ancestors 1,000 years ago had responsible for this flourishing scholarship might not only give them a sense of pride, but allow them to be part of, to accept this idea that learning about the world is okay, that it doesn't go against the teachings of your holy book.
This gallery is now woken up, I'm pleased to say.
Hello.
And then another one over there.
Thank you. Within the context of science education in the UK, how important is the history of science and the process in which historical scientists came to their understandings to that education of science in the UK?
This is a difficult one, and not all science educators agree on this. But because there's syllabus is being squeezed, and you want to make sure that you infuse youngsters with a bit more up-to-date science. It's not all that it was all done and dusted and done. Never mind 100 years ago, 1,000 years ago. But actually, I find, I know a lot of people do find, that the ideas do come alive when you realise they originated in the mind of someone who has a personality, has a character, that made mistakes, that went up sort of blind avenues. It's, humanising it and bringing it, telling it in terms of stories is vitally important. Rather than just this is a theory or an equation or an idea that is disembodied from the person who came up with it. I think somehow makes it a lot colder. But yeah, it's finding space in the syllabus. And I'm not suggesting finding space to teach about these. I mean, never mind these scholars of the Islamic world, but, how many kids at school learn about, Galileo and Kepler and Copernicus?
Lady in red at the end. Yeah.
The short answer is, of course, in writing this book and learning about how, the history of these ideas, it was quite a revelation to me, because in science, you're either right or you're wrong. In history, you can have several opinions, as long as you go back to primary sources. You can interpret the importance of particular ideas and attribute them to different people, and it seems that it's much looser. I don't know whether the issue that you address has something to do with a throwback to colonialism. That certainly Britain and France, when they're subjugating that part of the world, it wasn't quite right for them to promote the idea that these people who we are subjugating were once the great scholars, and it was Europe that was scraping around in the mud and the filth and the dirt, Because I went to school in Iraq, for me, the Crusades are seen through a rather different lens. These are a bunch of, uncouth, unclean, uncivilized, hooligans coming, raiding a wonderful culture. And so, yes, it may be, I don't know. I don't know enough about it to be able to make a point.
Byzantines in Constantinople took the same view.
Yes, yes, quite. So it may be an issue of colonialism that we still haven't addressed yet. That why shouldn't we give equal credibility and credence to sources other than those that have come through the well-known European scholars? Maybe it'll change.
Reg.
Your famous men seem to be running around out in about the 12th century, but isn't it true that there's still a hell of a lot of interest, particularly in things like astronomy, for quite a considerable time after that? I seem to remember what on holiday was, I was told that Timor, Tamerlane's one of his grandsons, actually made a series of measurements of star positions which were accepted as accurate for a very long time.
Absolutely.
That was the 14th to 15th century.
Yes, and in fact that's you know an issue that a lot of people don't realise, that the scholarship in the Islamic Empire didn't suddenly stop. It went into slow decline, and it depends on which particular area you're talking about. So something like astronomy or mathematics, you're right. There were cities in Central Asia, Samarkand and Bukhara and places like that. Samarkand, right, absolutely. I mean, there was a great mathematician there, Al-Kashi, who 15th century, I believe, wonderful advances in mathematics and arithmetic that, you know, so way beyond the period when we think the golden age of Arabic science died. It didn't suddenly stop. It carried on in slow decline, but to a large extent, a lot of that decline is in contrast with the rapid rise in Europe.
Now, we're very protective of our president. We don't want to wear him out. He's only been in office for less than a year. So I'm going to see if there are any more burning questions, and then we'll draw to a close. Yes, there's one at the back here.
I just wanted to go back there to talking about how there was the motivation, for example, to use mathematics to know which way to point to Mecca. But I was looking at the sort of motivation behind the patronage of the sort of great thinkers of the time. Did it sort of move beyond that it became like a culture symbol, or there seemed to be applications throughout the empire that could have, in other words, what were the other driving factors to help this sort of field of science?
It did become a badge of honour. It was something that, it wasn't just one or two people. Across the whole of, you know, the upper echelons of the Abbasid dynasty in particular, it became de rigueur to, you know, to, that's what you did. That you provided patronage for someone to translate a particular text. It was part of the culture which to a large extent they inherited from the Persians. That was the thing that was done. After that, with the fragmentation of the empire, you see these pockets of excellence. Certain dynasties and sultanates that wanted to show how civilized and powerful they were, they would use the patronage of scholarship and learning as a symbol of that. So there would always be a tug of war. Certainly people like Ibn Sina, Avicenna, he was the superstar, you know, and these different rival sultanates would offer him, would try and out, like a top footballer, you know, to transfer fee, and they would want to get him to come and work in their courts and lecture and talk to them about mathematics and philosophy and medicine as a symbol of their power. So that was certainly something that continued for some time. But of course, not all parts of the Islamic Empire were that interested. The Ottomans, for instance, were a wonderful, powerful empire, not that interested in science. I mean, there are examples, of course, but in comparison with the Abbasids 500 years or so earlier, there's a big decline in interest in scholarship.
Right. Nobody else? Well, in that case, that sounds
Good.
like a good opportunity to bring this meeting to a close. And I thank you all very much for coming. And I think we've had a very interesting discussion, a very interesting talk, which I thank Jim Al-Khalili for giving us. Can I say that on your chairs there's information about how you can come to more of these sorts of interesting talks, both locally and nationally in the BHA. So with that, may I invite you to express your thanks once again to Jim Al-Khalili.